In this video, we're going to be talking about transformations of graphs, okay, and how to graph them. So there's different types of transformations, and we're going to start with the easiest type, and those are just vertical and horizontal shifts. Okay, so this is when we move the graph vertically or horizontally. Okay, so let's just do two sort of an example of each. So if I have a function f of x, and we want to think about the graph of f of x plus k. Okay, so we take the old y value and we just add k to it. So this is going to be a vertical shift. So we're just changing the y values by shifting them up by k, if k is positive. Okay, so you just, if you have a vertical shift, you just add k to the y coordinates. Okay, so if I had the graph, for instance, of x squared, I'm just going to plot a few points here. So 0, 0, and then I have 1, 1, and let's do -2, 4. Oh, actually no, because we're going to move up. Well, we could do that. And this is 1, 1. Okay, so my graph looks like this initially. Okay, but now I add 1 to it. Okay, so in this new graph, we just add 1 to the y values. Okay, so our old point, instead of being at 0, 0, is now at 0, 1. Right, because I took my old y value and added 1 to it. The point 1, 1 has been moved to the point 1, 2, and the point -2, 4 has actually been moved to -2 and 5. Okay, but the shape of our graph is the same. So we didn't do anything except shift it up by 1. Similarly, we could also do a horizontal shift. So when we do that, we subtract h inside the function. Okay, so with the x value. So these ones are a little bit more complicated. And it's going to shift h units to the right, okay, when it's a minus sign. So if you have a horizontal shift, what you're doing is you're adding h to all the x coordinates. Okay, so we're going to try another one. So here is the graph of x cubed. So we have we have these 3 points, just to give you a taste of what's going on. Okay, so this is the point 1, 1, 0, 0, and -1, -1. Okay, so now what we're doing here is we're going to add 1 to all the x values. Okay, so instead of being at 0, 0, it's going to be at 0, 1. Instead of 1, 1, we're going to be at 2, 1. And instead of -1, -1, we're going to be at 0, -1. But our graph is going to have the same cubic shape. Okay, it's just been shifted over to the right 1. So this is now 2, 1, 1, 0, and 0, -1. So we just add 1 to each of the x values. Okay, now just a reminder, okay, so if your value is being added to the entire function, that's when you get a vertical shift. If it's being added to the x value, okay, that's when you get the horizontal shift. So notice here the -1 is with the x, but here the +1 is on the outside. Okay, now maybe just a note here. So if we think about the this one here, you could actually think about it as y -1 equals x squared. So you're actually doing the operation to the y value. Okay, but when we solve for y, it ends up being over here as a +1. But then it might make sense that the -1 goes up and the -1 here goes to the right. Okay, so it's kind of works the same way. So maybe that sort of talked about this question a little bit. But so because it's a minus, it's x minus 1 or x minus h, you might think that it should go to the left h, okay? But instead it goes to the right h. So why does that happen? So if we think about the vertical shift, okay, so I have y equals x cubed minus 1. This transformation affects the y coordinate because it's on the outside. It's not in the cube. So the 0.28 is on the basic graph. The x value stays the same, but the new y value is going to be 1 less. Okay, so 2,8 on y equals x cubed means that 8 is 2 cubed. Okay, so then if I want, I still want to use the 2. So if I plug in 2, it's going to be the 8. Sorry, not cubed. Okay, so it's going to be the 2 cubed, which is 8, but then the minus 1. So I actually just subtract from the y value. Okay, so this is the old, oops, I should have wrote y equals. So in the new one, this is the old y value, and we just subtract 1 from it to get 7. Okay, so the new y is 7, which means the new point, it still goes with the number 2, but it's now 2, 7. Okay, now for the horizontal shift, so now I've written the x minus 1 inside the cube. So because it's with the x, we know it affects the x coordinate. So 2,8 is on the original. Okay, so that means that we know 8 is equal to 2 cubed. So if I want the same y value, then we need 8 to be equal to x minus 1 cubed. So we need this part to equal 2, which actually means that x is going to be 3 here. Okay, so that means our new x is equal to 3, and the point becomes 3, 8. Okay, because the minus with the x is reducing the x by 1, so I actually need a 1 bigger x in order to have the same y value. Okay, so that's what's going on there. Okay, so let's put these together. So here I want to graph the function f of x is x plus 2 cubed, cubed minus 1. Okay, so this, because of the cube there, this is the y equals x cubed graph shifted. Okay, so we're going to start with y equals x cubed. Okay, so we're going to do sort of one shift at a time. So we know what the y equals x cubed graph looks like. Okay, so it's something like that, and I have those 3 points. Maybe I want to write the coordinates, so 0, 0, 1, 1, and -1, -1. Okay, so now what I'm going to do is do the horizontal shift first. So I want to graph over here, f of x equals x plus 2 cubed. Now this is x minus -2 cubed. So when it's plus inside, we're going a negative distance, so we're actually going to move, so this one's going to move 2 to the left. Okay, so instead of being, so this point, instead of being at 0, 0, is going to move 2 to the left. Here, instead of 1, 1, we're going to move 2 to the left. Okay, so similarly, this point down here is going to be there, and I'm going to have the same shape, but at these new points. Okay, so this is -2, 0, -1, 1, and -3, -1. Okay, now I'm going to take this graph and I'm going to subtract 1 from it. So now I want to graph my final function. So it's the graph that we just had minus 1. So here, now we're going to shift down, okay, 1 unit. So all these points are just going to go down 1. So they're going to end up like that. And my graph is going to look like that. Okay, so this is going to be -2, -1, -1, 0, and -3, -2. Okay, so you can see you can do these in steps. So this thing might have been hard to graph initially, but because we know the x cubed graph, we can just manipulate that and then get our final graph. So now we know what the graph of this function looks like. Okay, you can also vertically and horizontally stretch or compress the graph. Okay, so instead of just shifting it, you're sort of stretching it. So if you have the function f of x and you think about a times f of x when a is positive, this is a vertical stretch. Okay, so what you're going to do, I'm going to try and get a new color here. So if you have a vertical stretch, you're going to multiply the y coordinates by a. So notice that the a, just do that. Okay, the a is timesing the f of x, so that's the y value. So you take your y value, times it by a. If a is less than if a is less than 1, so like a fraction, then a stretch by 1/2 is the same as a compression by a factor of 2. Okay, so let's just see an example here. Okay, so we know what the absolute value graph looks like. Okay, so there is my graph. Now I could have a few points here. Maybe I do this one. So this is -2, 2. This is 0, 0. And here, say, we have 1, 1. Okay, so when I do this 2 times the absolute value x, we're going to multiply the y value by 2. Okay, so that's going to shift it. So 0, 0 is going to actually stay in the same spot, but 1, 1 is going to go to 1, 2. And -2, 2 is going to go to -2, 4. So you see, the graph looks the same, except that it's been vertically, like you pulled the ends and you pulled them up. Okay, so it's been vertically stretched. Okay, so that's what the graph of that one would look like. Now, if the a is inside with the x, this is called a horizontal compression. And I need a new highlighter color, so maybe orange. So horizontal compression means you're going to divide the x coordinates by a. So it's the same as multiplying by 1 over a. So let's see an example. Okay, we're going to do the same example. So let's draw the absolute value graph again. Okay, now when I do, so actually let's pick a few points because I want to divide. So here I'm going to divide the x values, okay, by 2. I kind of want to pick even ones, but okay, so here I have the point 2, 2. Here I have the point -2, 2. So what's going to happen, so 0, 0 is going to stay the same. Okay, but now 2, -2 is actually going to go to 1, -2. -2, 2 is going to go to -1, 2. So this is 1, 2, and -1, 2. And your graph ends up being sort of a horizontally squished graph. Okay, so we compressed it horizontally. Okay. Now notice that these two actually look the same. Okay, they actually have the same coordinates. So these are actually similar, the same. So if you vertically stretch by 2, it's the same as horizontally compressing by 1/2. Okay, so that's with the 2 in there. Okay, now I'm going to skip these, so I want you to try them. But let's do one where we sort of combine some operations here. Okay, so now notice that this one is the cube root function, okay, being shifted. So that's what we're going to start with. So we're going to start with f of x is equal to the cube root of x. Okay, so for that one, it looks, okay, something like that. Okay, and then what I want to do is I'm going to do the 2 on the outside first. Okay, so I'm going to take my old y values and multiply by 2. Okay, so we multiply y values by 2. So that's going to give me 0, 0 is going to stay. Okay, but 1 is now going to be at 2, and -1 is going to be at -2. So it's going to vertically stretch out this graph. So it's going to look something like that. Okay, now I want to do the final one. So this is going to be f of x is 2 times the cube root of x minus -1 or plus 1. So now we're going to shift left, okay, 1 unit. So instead of being at 0, 0, I'm going to be at 0, 1. Okay, 1, 2 is going to be at 0, 2. And that one's going to be there. And my function's going to look something like that. Okay, so that is how we can do multiple with the shifts in there, or the stretches, I mean. Okay, now these examples I'm going to skip for you, so please try them. Okay, it's a bit easier function with the quadratic, so you can use more points if you want. So let's talk about the flips. Okay, so another type of transformation is a flip over an axis. So we have the vertical or the horizontal flips. Now I'm going to need some more colors here. I guess I haven't done this one. So if we have a vertical flip, okay, then we're going to flip over the x-axis. Okay, so the y values get multiplied, okay, by a -1. Okay, so for example, if I had the square root of x, okay, that is going to look, okay, so there's the square root function, looks like that. So if I have negative, all I'm going to do is flip over the x-axis. So I get something like this instead. Okay, so all the points that were above the x-axis are now below the x-axis because of this -1. Take the old y value and put a minus out front. Okay, now the horizontal flip, do it in red. Okay, so horizontal flip is going to flip over the y-axis. Okay, so to follow our rule, okay, the minus is like the a, so it was f of a times x, and then we divided the x term, the x values, okay, by a, which is -1 here. Okay, so that's going to flip it over the other way. So if I have, again, the square root function, looks like that. And if I have negative in front, notice that this is going to change the domain too. right? So all of the positive x values that I could initially plug in, I now can't because this negative makes them negative. Okay, so the domain changes here for this function, but we're going to flip over the y-axis. Okay, so now if I plug in -1, I get -1, and I get the 1 value. -4 is going to give me the 2 value. So I flip over the y-axis. Okay, now in this chapter, we're not going to combine too many of the transformations. Okay, so these are the sort of what you might see, the hardest ones. Okay, so this is a vertical stretch, a horizontal shift, and a vertical shift. Okay, and over here, okay, we have the vertical stretch and the horizontal compression, but no horizontal movement. Okay, so we're not going to combine the horizontal shift, the horizontal shift, I did it again. I want this thing, the horizontal shift with the horizontal scale and or flip. Okay, so we're not going to have to do two horizontal things at once. Okay, now the order you do the transformations matters. You don't have to do it in this order per se. So these two sometimes can be switched, which I actually did in the previous example. But the vertical shift has to be last. Okay, and if we did combine these things, then the order would be even more important. But because we're not going to, this order is fine. So you can do the horizontal transformations, and then the so that's the shifts. Maybe I should write that. So this is shifts and expansion or compressions. That's right. Okay, and then you can do the vertical scale and flips, but the vertical shifts have to be last. So that's the order we're going to try to do. Okay, so okay, so let's do this example. Okay, so here, this is obviously what we start with is the absolute value function, and then we've transformed it. Okay, so we're going to start with the absolute value of x, okay, which we know looks like this. Oops. Okay, and I mean, you can have a few points on here if you want. So 2, 2, -1, -1, etc. Okay, now I'm going to go this way. So it wants me to do horizontal things first. Okay, so this negative on the outside is a vertical thing. So I'm going to do the 2. So my next function is going to be y equals x, absolute value x minus 2. So that's going to be a shift right 2 units. Okay, so I just move everything to the right. So I'm going to get something like that. It's the same. So this one now is 4, 2. This one is 2, 0. And then I have 1, -1. Okay, now I'm going to do my negative. Oops. So now I'm going to have my f of x function, which is negative the function before. Okay, so now we're going to flip, okay, over the x-axis. Okay, so all I do is I keep the ones that are on the x-axis the same, and I just move the other ones over. So the 1, -1 now is 1. Oh, this isn't -1. This is 1, 1. Okay, so 1, 1 now moves to 1, -1, and 4, 2 moves to 4, -2. And I get the same shape, but upside down. Okay, so that's combining them. Okay, now I'm going to skip this example and this last example for you. Okay, so give those a try. This is combining. This one might be nice to note that you might want to write this as -2 times 1 over x plus 1. Okay, which is actually -2 times 1 over x minus -1. Okay, so the graph that you're going to start with here is the 1 over x graph. Okay, so keep that in mind when you're doing that.